Hey guys, how's it going? So in this tutorial, I'm going to show you guys how to plot the powder X-ray diffraction pattern using Origin. So in the last tutorial, I showed you guys how to convert the raw data file generated using any popular X-ray diffractometer into a readable format. So in the last tutorial, we came up with this file converted.xy which contained the x and y axis values for the XRD pattern. So this was converted using powdll, and in case you have the raw file only, then you can refer to that previous tutorial that showed how to convert the raw file into a readable format. However, if you have these x and y axis data values, then you can continue with this tutorial. So just go ahead and select all these two columns and then open Origin and paste these into a worksheet. So just press Ctrl+V. So in the x-axis values you have the theta angles, and in the y-axis you have the intensity of the peaks. So just go ahead and select these two columns and right click on them, then select plot, line, and then line. So here you can see a nice XRD pattern in your Origin graph window. So the first thing that you'd want to do is you would want to label the x-axis. So it should be called 2 theta, and the way to enter theta or any other Greek alphabet in Origin is to just go ahead and click here or press Ctrl+G. So that is a shortcut that would select this theta Greek format, and then so theta basically corresponds to Q on the keyboard. So if you press Q on the keyboard, then in Greek alphabet you would get theta. So you have theta here, and then what you want to do is you want to enter the units, so that is degrees. So you can now get rid of this Greek alphabet and enter the units either such as this, degrees, or you can just write O in the superscript format by selecting it and selecting this superscript here. So here you can, so there are a variety of ways you can write or label the x-axis. So whichever you prefer. However, I usually prefer writing degrees explicitly, so I'll just go ahead and and write degrees here. However, you can do it in any way that you like. So here we have labeled the x-axis. Now the next thing would be to label the y-axis. So just go ahead and double click on this here, double click, select all this and write intensity, and in the parentheses you can write the units, and basically intensity has no particular units and it's just arbitrary units, so you can just go ahead and write that. So here you have that, and another way would be to just write ARB in the shorter form, so arbitrary units. So now we have labeled the y-axis as well as the x-axis. Now the next thing that you might want to do is you might want to get rid of all these labels or these values, because intensity usually is measured in arbitrary units, as I already said. So basically the highest peak is scaled to 100 and all the other peaks are scaled relatively. So basically these don't offer any useful information, so you can just go ahead and click on either one of these, so and then just press delete on your keyboard, so you can get rid of these if you want to. And you can also control the number of these minor and major labels or ticks that you are seeing on the axis. So just go ahead and double click on this axis. Sorry, it didn't work quite the way I wanted to. So just go ahead and double click on it and select tick labels, and here you can select the number of minor and major ticks. So currently the number of minor ticks is set to 1, so you can just go ahead and select 0 and click on apply. So that would get rid of all those minor ticks, and you can also select the range from which the y-axis is starting. So currently it is started from -20, so you can choose 0 instead of that if you want to, so that would just bring the whole graph down. However, usually I've seen it's better to have that kind of offset, so I'll just go ahead with -20. However, it totally depends on you what you want to do with your graph. Then the next thing would be to edit the x-axis. So in the x-axis there's not much to do, I guess, because all this information is pretty necessary. So the only thing that I can think of here is I would like to bring this here, because in my XRD in my X-ray diffractometer, I started the scan from 10 degrees to 80 degrees. So I'll like to start this graph from 10 degrees. So in the scale section, I'll just go ahead and select 10 here and click on apply. So that would start the graph from the origin, or at least from the 0 x-axis. And then what else? So this is all basically pretty much it. However, you can do further changes, like in case you want to provide more than a single minor tick in the x-axis, then you can again go to scale and select the number of minor ticks as 5 or whatever you want. So here you will get more minor ticks in case you want to, or you can get rid of them altogether. So there's a lot of customization that you can do in Origin. So that's it. And one last thing that you need to do is you need to label these peaks. So usually the peaks are labeled through the Miller indices corresponding to the H-scale planes. So to label those, what you can do is basically just pretty much copy this text box right here. So just click on it and then press Ctrl+C on your keyboard, and then just press Ctrl+V in near different peaks. So just click with your mouse and then press Ctrl+V. So you are pasted this text box in a lot of peak locations, and then what you can do is just double click on it and write down the index of the peak. So let's say the first peak was 100. The first peak was corresponding to the 100 plane, so you can just go ahead and do that. Then double click on this and select or write down any other plane like 102. So that way you can basically, then again you can copy these and then paste them on different peaks, and that way you can label your peaks with the corresponding H-scale indices, or the Miller indices, that is. So that is how you would label the peaks. And finally you can basically in the legend you can write down whatever this black line corresponds to. In my case it is basically the alpha Fe2O3. So again, alpha can be written using the Greek notation by pressing Ctrl+G on the keyboard and writing A, and then Ctrl+G back, and then Fe2O3. So this would be handy if you are plotting multiple XRD patterns in a single window. And I'll make another tutorial that shows you how to plot multiple XRD patterns in a single window using the stack plot. So here is that option in the stack plot. So you can just in the next tutorial I'll show you how to perform a stack plot. So probably we'll be using stack lines by Y offset in that video. So that would be your answer if you want to plot multiple XRD patterns in a single window. So that's it for this tutorial. I hope I have covered all the necessary basics. And one more thing you can do with the peaks is you can analyze them to calculate the crystallite size using the Scherer formula. So in order to do that, usually what you need to do is you need to perform Gaussian fit on a peak, and I have already made a video on that. However, I'll just quickly go ahead and show you how to do that. So just use the zoom option to zoom into a peak, and then what you can do is you can select the data points corresponding to the peaks by using this regional data selector, and then select this region on which you would like to perform the Gaussian fit, and then go ahead and click on analysis, and then peaks and baseline, and you can go to peak analyzer, multiple peak fit, and all that stuff. So I'll not show that whole process in detail in this video because I've already made a tutorial on that, so you can just go ahead and check that out. However, for this tutorial you can just clearly see that it is only using the selected data points that I have provided, and then you can select the peak functions. In my case I'll be using Gaussian, and then just go ahead and click on OK, and then you can just go ahead and double click on the peak. So here it is, and then click on fit, and there you go. So here if you come back to the graph window, then you have this table displaying all the necessary data of the Gaussian fit, and you have the all the information, especially the most important information for the crystallite size using Sheriff formula would be the FWHM, which is this quantity right here, 0.2394. And remember, this is in degrees, so you'll need to convert that into radians while you do that experimentally. So that's it. I hope you guys enjoyed this tutorial. Thanks for watching, and in case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.